All right, so I think that should be good enough. All right, you've either tried it and figured out most part, right? Or maybe I think a lot of you have probably already worked out everything. So now if this were a test problem, it will be most likely an FRQ. Right, so you make sure that you show me the work so that you get up to 5 points. But you see that there's only 2 missing angles plus a side, right? So I guess that you can get 3 points, 3 points for just the answers, right? Get them right. With the remaining 2 points, go to the appropriate work. And this way, finding the angle or the size, I mean, the order doesn't really matter. If you see that we have a right angle, right, and the 2 sides already given. One of the shorter sides, right, and hypotenuse. I mean, maybe finding the missing side is more intuitive, right? So you can just use the Pythagorean theorem, right? So let's take the square of AC subtracting the square of BC. Okay. Plug in numbers. 11.9 square minus 7 square under square root. I think that if you already worked it out, check that. The answer my student from last period told me is about 9.6. And if you wonder how many decimal places should you run, I'll say usually 1 decimal place is good enough. Okay, but if you do get more or less, don't worry. If I can tell that you're getting the right thing or close enough to what I got, you'll be fine. Because again, free response, right? So we do have some freedom to grade the work in the way we want, because the goal is to see if you've mastered the skills, right? Not try and be nitpicking. Okay, so now we have all the sides, right? So let's find out the angles. So let's say if I want to find out the angle A. So why don't you tell me, or anyone feel like sharing with the whole class, what inverse trig functions you feel like using to find out angle A? Sine, okay, so I sense there will be inverse sine, right? So inverse sine, but that takes the ratio of opposite over hypotenuse, right? So it'd be opposite BC, right? That's the opposite of angle A, right? Hypotenuse, is AC. All right, so plug it in. Sine inverse of BC is 7, 11.9. Right, and you work it out. Let me do that in decimals so that we'll talk about some issues. There might be issues with radians and degrees, right? So make sure that well, of course, decimal is just very user friendly. So you make sure that you know how to go back and forth between the radians and degrees. You might be better off in degrees for the most of the time for the test, but for a question like that, make sure you switch in degrees. So there is a separate button for those inverse trig functions. Okay. So be careful with doing something like this. Right. So maybe you figured out, oh, it's sine inverse, right? Let me just do, I think that you have a way to putting a -1 power, right? So if you do sine, what do we want? 7, right? 7 divided by 11.9, right? But on your calculator, you typed in this whole thing, right? Raised to the -1 power, right? You thought it's sine inverse, right? Is that right? What is that? That's sine of the angle, right? So for some reason that you want to specify the angle as 7 over 11.9, whatever that angle is in radians, evaluate the sine and take the reciprocal, that gets you what? Cosecant of this angle, right? And it's very different from putting sine inverse, which is a different function than sine, and evaluate sine inverse at this exact ratio you want, gets you the corresponding angle. You see how different they are, right? This is just some kind of a ratio, right? But this is actually in angle, around 36 degrees. Okay, so make sure that you find that separate button on your calculator, and realize that you're 1 degree in this case instead of radians. Right? So that's 36, roughly 36 degrees. Okay. So now for the remaining angle, hopefully you realize that it's nothing but the complementary of 36, right? So you could just go ahead and take 90 minus whatever you get for angle A, right? So it'll get you 54 degree, right? But if you insist, you want to use a inverse trig function to find out angle C. What can I do? Well, now I have all three sides, right? So you have the freedom to use any of the three inverse trig function. Right? So now, what if I insist I want to use inverse tangent to find out angle C? How should I type in? Inverse tangent, what should I put here as the ratio? Angle C is right there, right? So inverse tangent takes the ratio of tangent, right? Opposite of adjacent. So you're going to have to look for the opposite of angle C, which is 9.6, right? The adjacent 7. Right, so you do 9.6 over 7. And I'm sure that you're going to get something close to 54 degrees, right? Or you know what? Can I do inverse cosine? Can anyone tell me what should I put in inverse cosine to get the angle C? 7, okay, so it'll be adjacent of my hypotenuse, right? 7 over 11.9, right? But the adjacent and opposite are relative speaking, right? If you're looking at a certain angle, make sure that you know what angle it's looking at and find out the proper sides, and it'll still be 54 degrees, right? But practically speaking, why would you do that, right? Isn't the complementary angle a lot easier to find, right? Instead of going through the inverse trigs, right? And again, if you're wondering what decimal place you want to run to, just ask me in the test. I'll tell you. But here's might be a little issue. You may or may not, lose the point. So let's say you've got 36 degrees for angle A, and you decide to go with the harder route, to get, the inverse trig to work out, right? And for some reason, because of all the rounding issues, you get an angle that you end up being rounding down to 53 degrees. But now do you see that 36 and 53 don't add up to be 90, right? But I see it, it's off by 1 degree, right? It's gonna be, point something here and there, right? So I'll be reasonable. If that happens, I'll still get you the points. But I'll say that, why would you do that, right? Just subtract, that from 90 and get yourself the angle. But my point is, rounding is not a big deal, right? After all, you're taking a math class, not a science or engineering class, right? Anyway, so like I said, there might be problems like this, missing all the angles, right? Except for the 90 degree. So you figure out the side, you figure out the angles using inverse trig, right? But there could be a problem like, if I scroll it up, like number 1 and 2 on that worksheet. So they told you one of the angles so that you might want to find out the complementary angle right away, right? And then use the angles and the only side that you're given to find out the missing sides, right? Using the regular trig functions, right? Not the inverse one. But I hope that sometime next week I don't have to go over these kind of problems in class, and I'll save more time for some other tricky ones. Right? But if you had a hard time with those kind of problems, or even with using calculator, feel free to stop by, during my office hour. Right? Oh yeah. So I need to mention, in case I forget, the test will be most likely next Thursday. All right, so it'll be the last official teaching day before the spring break, because Friday, well, we still have class on Friday next week, but it will be a test prep thing. Now, it hasn't been finalized, but me, Professor Thompson, and also Professor D proposed, next Thursday, right? So we're still waiting from, 2 more instructors, but I think that most likely will be next Thursday. So that means, we're, oh yeah, go ahead, Alex. No, I decided not to give you guys another quiz before the second test. I feel bad for missing a day, right? But that's not the reason I don't give a quiz. Well, there will be 2 more tests after the second test. There will be plenty of time to get quizzes, and it only counts for like 10% or something, right? 10, 15% of the grade, right? It won't make a big difference, okay? But I'll definitely let you know if there's a quiz posted. I usually do that way ahead of time. So there's a quiz, and you have to come by, and you hear me keep mentioning that, hey, come and get a quiz done. But there's not going to be a second quiz this time. What else? All right, so now we're on 5.8, and I'm not going to be able to finish 5.8 today. But you guys do realize that the homework 5.8 is due this Friday, right? So I'll finish 5.8 tomorrow. It's just that the schedule we had at the beginning of the year has changed, right? Once to make the test, a little bit earlier, right? But then now we realize that, the test 2 is just a bit, so we have to, get a little bit more time. So we will have more time than we expected to review for a second test, which is always good. But like I already told the first period student, now, if you had a good grade in the first test, then you have many reasons to make the second test, work out even better, right? Because I'm sure if you do see how seriously we're taking those test review questions, right? Why we're giving you those test review sheet. And not to mention, since there will be 4 tests, right? They all get counted as like a 40-something% of your grade. You can imagine that when you have 2 super good test scores. And let's say if you do end up being screwing up, one test, right? Test 3, test 4. Remember that the lowest test grade can be replaced by the final, right? And usually the final works out better than the test for some reason. So you just have to make sure that you don't screw up 2 tests, right? So your grade will be, protected by 2 good test scores, right? So you can, relax a little bit. Yes, Anaya. So Anaya's question is, is the final this semester the department final, right? So like we don't get to make our questions, straight from the college, no, we make the questions this time for the final. Right? And it's the same policy that the final grade will be replacing, if you want, the lowest test grade. But don't get me wrong, if somehow that the first test didn't work out as the way you wanted, right? Can you imagine? I said that to my student last semester. If you make the second test work out, then you will see a big jump in your grade. Because right now, the reason why the grade is not as good as you thought, since you may have a perfect grade in a quiz and a homework, right? But there's just one test, which is weighted 40% of your overall grade, right? If you screw up a little bit, your overall grade right now reflects pretty much on the test, right? We have 2 tests. Let's say I said, if you get a C in the first test, you get an A in the second test, average out to be a B, right? And that B is going to make sure that you definitely get a B or even above, way much above than a B overall. So there's tons of reasons that why you should have the test to work out, okay? But you guys remember that in fall semester, test 2 was the midterm, right? Well, the good thing and bad thing about having the second test is a midterm. If it's a midterm, it will be accumulated, Means it covers everything from 5.1 to 5.8. Okay, but you're gonna like if it's a midterm, because if it's a midterm, it will be multiple choices, all multiple choices. Right? That's what I understand, right? But unfortunately, this time it's a test 2. It covers only 5.5 to 5.8, and it has 3 responses. Okay. So right now, I've done 2 drafts already. The second draft is on a review. The number of questions is the same, right? We just do some fine tuning of the questions. So it'll be 10 multiple choices, and 5 FRQs. All right, so most likely. And again, the way I grade those questions is, I just get your percentage, for the multiple choices, right? And also your accuracy for the FRQ, right? And average them, right? So I'll make sure that, if you do show me those reasonable work, if you do screw up a little bit in the math, right? Which you shouldn't, you have a calculator, right? But don't get paranoid, you still get most of the points for FRQs. So that's why, seriously, when you guys prepare for the second test, don't make the same mistake like some of the students did, in the first test. They didn't get themselves enough time to work on FRQs. You know how easy it is to screw up those multiple choices, right? One wrong, is what, like 10%, right? Because there's only 10 questions. Not to mention that you cannot show me the work. You might say that, Dr. Wang, I understand it. It's just, for some reason I didn't pick the right answer. I believe you, right? But there's no I can give you a point for. If you put the wrong answer, it's wrong. All right. FRQ is different. If I can see that you're on the right track, then you will be getting more points than you can imagine. Oh, Russell. Next Thursday. No, there's no quiz 2 this time. Right. Anyway, so one more thing. Since you guys remember, the packet that we'll be using are for only 5.5 to 5.7, and this morning facility want me to give an updated version for the test review. So yes, I'm making a second test and also making a test review. Okay. So that's why here there are 2 packets now. The second packet, the problem is not exactly the same, but they're pretty much the same kind of a problem, right? Some of them are probably with a different number. So when I finish 5.8 tomorrow, so when you guys come back, maybe next Monday or Tuesday, I'll be seriously looking into those questions, especially the ones I've added for 5.8. Okay, and I'll say it will be the last few questions. There were 50 questions in the original packet, right? We went over most of them in class, believe it or not. And I've added quite a few questions, but you will see that when we go over them, some of them are just repetitive, right? I might not, go through all the questions. But what will be the best for our test review is that you have a long weekend, right? If you can spend some time, just starting from, let's say, question 49. You guys see that, the right triangle thing, right? That's what we did in 5.8. Start from 49, pick a few questions, work them out, find some issues, right? And bring it to the class next week, right? So that will, be the most efficient way for you guys to get yourself prepared for the second test. Anyway, now today we're gonna take care of the second learning objective, which is about bearings. So I don't know if you guys have heard of what bearings stands for, or let me show you the textbook that says bearing is like a professional way to specify the direction, right, of a certain object. I think that's mostly for navigation purposes. So, well, in South Florida, you have all those, water, right, water sports. Or if you go sailing, right, if I've never tried that before. So you know that people need to tell the direction by the location of the sun, right? When they're in an ocean, there's no reference they can find. They need to know what direction is north and communicate with people on a boat or maybe some other boats, right? Relative location of boats or whatever, what direction they're heading to. So basically, we need to find a reference direction, and it's going to be the north and the south line. Okay. So now let's say if I'm standing at this point O, facing straight north, I see an object to my right, and it's about 40-degree angle to my right. If I'm facing north, right, to the right is east, right, to the left is west, and backwards is south. Well, how do you specify that direction? So the direction OP, you say north 40-degree east. So north is the reference direction you're going to start with, right? And then you're going to say the angle, which is the angle you're going to turn into the direction you want it, right? But you know that it makes a difference. If you turn to the eastward direction, sweep out angle 40, or turn to the west, right, sweep out 40, right? So it depends on where the object is on your right or on your left. Now let's try this real quick. So we're in building 11, right? So building 19 is somewhere over there, right? I think that this is pretty much like straight north, right? So let's say I'm facing north. So the building 19 is somewhere over there. The angle between, the perfect north direction and the direction I'm facing the building 19 is about, let's say, 30 degrees. So you're going to say the bearing of building 19, right, will be north 30 degree east, because to the right is east. Let's see. What about building 10 on 8? Right there, right? But now, see that if this is north, but building 10 on 8 is right behind, right? I have to turn the other way facing the south, right? Because the reference direction could be north or south, but only those two, right? So now I'm facing south, right? And building 10 on 8 is about, to my left, say 60 degrees, okay? So how do I say? The bearing of the building 10 on 8 will be south, right? Then 60 degree west, right? There you go. That's how simple it is. So that's called bearings. Now let's let you think about these two problems for a minute. Then we'll let you know the answers. All right, go ahead, give it a try. All right. So let's do it together. A bearing from O to D. So O to D. So that's the direction you want it, right? So that's sort of like closer to the south. So I guess you can start from the south, right? And then label the angle 25 degree. Oh, by the way, so the angle in the bearings must be less than 90 degree. That's always going to be acute angle. So you should say south, right? 25 degree east, right? See that? It's on the east side, right, of the south, right? You're facing south, turn to the east, right? by a small angle. Now OC. Well, again, you might still want to start from the south direction, right? But now you're turning to the west, not by 75 degrees, right? But it's complementary, right? So now it will be what? South. Well, I guess that small angles will be 15 degrees, right? 15 degree west. Right, does it make sense? That's all, right? So order does matter, right? Make sure you always start from either south or north. In this case, we start from the south because the angles would be greater than 90 if I go with the north, right? All right, and this is actually one of those questions I picked for the test review, so you know that it's as simple as this seems. Now, but there could be FRQs, like the number 6, example number 6 in the book. It does have some bearing concepts, and it's a word problem, where you have to extract those information correctly. But then at the end of the day, you're end up doing the right triangle, right, solving process, right, using the inverse trig to find out angles, right? It's kind of messy, but let me erase that and quickly go over this real quick, and we'll do a problem like that, just to illustrate if there's a word problem about bearings, if there are any little subtlety you have to go through. Anyway, so let's read the problem together. The boat leaves the entrance, which is right here. All right, so if you don't mind, let's call it point O. Travel 25 miles on a bearing of a north 42 degree east. They've labeled a north, right? And you know that to the right, oops, this is east, right? So start from the north, turn to east by 42 degree. Okay, so both ends up being here. Let's call it point A. So at this time, the boat is facing harder than I thought. It's facing so like to the top right direction, right? But then they say turn 90 degree clockwise. All right, it's going to turn in this direction. Then later the boat's going to turn or face this direction, right? And travel another 18 miles, get to the point B. All right, so now letter A says that how far is the boat from the entrance? So basically, letter A is asking for how much is the distance, right, between the point O and the point B. But as you see that, the reason why they say the boat turned 90 degree before the second trip, so that you can have a right triangle, right? You have the two shorter sides, right? One is 25, the other is 18. You're missing the longest side, and just solve for the approximate of the right triangle, right? And therefore, you see that it's just Pythagorean theorem and work it out, right? And I'm sure that you have no issues with that at all. But it's the letter B, right? That might be a bit confusing because you have to figure out the bearing of let me see what they want. Okay, what is the bearing of the boat from the entrance, right? The harbor entrance. That means it's someone standing at the entrance, looking at the boat to figure out in what direction is that boat, right? Relative to that point O. So, well, of course, you're gonna have to find the angle between OB and the northward direction, right? So it'll be that angle, start from north, going all the way to OB. You see that it's an angle composed by angle theta and at 42 degrees. If you find that angle theta, then add 42 to it to get the bearing angle. Now, the question becomes, how do you find the angle theta in that right triangle OAB? They say, look, you have the 18 miles, which is the opposite of angle theta. 25 is the adjacent, right? So hopefully that reminds you it's the tangent, right? Or inverse tangent you should be using, and plug in the ratio like you did, with, the right triangle solving problem. Inverse tan, 18 over 25. So you're going to get 35.8 degrees roughly, and that's not the angle, right? It's actually the sum of the 42 and 35.8 gets you 77.8. So that's that angle you needed to specify the bearing of the point B relative to the point O. Okay, that's it. Right. So I'll say that it's pretty much a right triangle solving problem in a real world situation, right? So you see why this problem might be so straightforward, right? Even though there's a lot of information there, right? It's because that they're so nice to provide you the sketch. But the problems that we hit from the question bank don't have those sketches. Okay. So make sure that when you try the homework problem or the problems that I pick for the test review packet, this is actually the first thing or even the most important thing you have to figure it out. And once you have a good sketch with all the angles and the size labeled as much as you could, then I will say that you're, I don't know, maybe 80% done for the problem. Because I don't think that anyone's going to have issues with solving right triangles. Anyway, so now let's see. There's a problem here, still from the textbook, but unfortunately, there's not a sketch. Why don't you read this problem for a minute or two, then we'll work it out together. Now, if you could, as reading the problem, can you draw a little sketch like you saw in a book, right? Mark the point O, right? Where this guy's gonna be, right, after both trips. Label them to get yourself a right triangle. That's all you need to do. All right, one more minute. You don't have to complete this, in a minute. I'm just saying that read the problem and hopefully get a sketch ready, then work it out together. All right, so that should be good enough for you to understand what they're asking for, right? What are provided. So this guy starts from say point O, right? So you know, he's moving in that direction, right? The bearing is south, 31 degree west, with a distance of 2.3 miles. All right, so let's go ahead and draw a segment. Let's call it like point well, OA. Right, so I wish I can let's get the O out of the way. All right, so the distance is 2.3, right? And the angle here is what is that? 31 degree, right? That small angle here, 31 degree. So now turn 90 degree clockwise. Well, so you tell me, if the guy does that, will he be facing to the west or to the south? So clockwise, right? So now can you imagine that I'm walking, right, in that direction from O to A, right? Then I'm turning clockwise. That means I'm looking at my right, right? And my right is the west. Sometimes it does make a big difference, right? So now the guy will be moving in that direction, right? That's the right angle. Get to the point B, right? And the distance is 3.5. And you have a right triangle. Okay. So now letter A is simply asking, what is the distance from this guy to the entrance of the trail, right? So it's asking for how much is distance about OB, right? So the segment OB is the hypotenuse, so it must be square root of OA square plus AB square, right? So plug in the numbers. So it'll be 2.3 square plus 3.5 square. Square root, and this is approximately 4.2. Thank you. 4.2 mile. Right? That's it. Right? Seems complicated, but it's very doable. Now letter B, the bearing. So the bearing of this guy's location, right, after two little trips, right, relative to the entrance. So basically, how would you specify the direction OB? So you have to refer either the north or south direction. But obviously, this guy is, you know, a bit closer to the south, right, than the north. So you want the angle away from the south, and then we label it with a different color. All right, so I need this angle. Still a acute angle, but goes from south all the way to the side OB. All right. But of course, you know, we need to first find out what the angle AOB is, right? Let's go ahead and find out angle AOB. So while you guys tell me, which inverse trig function would you use to find out the angle AOB? Tangent, right? Inverse tangent. That's right. So tangent inverse of the opposite of angle AOB, which is AB, right, over the adjacent, so AO. Okay, so put the numbers will be tangent inverse 3.5 over 2.3. Right, so it will be 56. Okay, so yeah, let's go with roughly 57 degree, right? But that's not the bearing angle, right? So the bearing, sorry about the handwriting, is the sum of the 31, right, and the 57, that's what, like 88, right? So it'd be south 88 degree west, okay? That make sense? You know, a pretty straightforward problem, right? But like I said, hey, it's an FRQ, right? 5 points for that problem. You know, I'll say that, you know, 1 point for each answer, right? Plus a couple points, you know, somewhere in the middle, okay? Visualize this angle. Okay. So the bearing is just a fancy way to say if you're always facing south or north. Yes, the whichever direction you start with is the reference angle, right? It always starts from south or north. In this case, it's gonna be the south. All right, cool. Yeah, you guys are good to go, but don't forget that the homework from 5.5 to 5.8 is due this Friday. All right, so please get started.